All right, folks, it's Bass Action back in action here. In this video, we are going to talk about rationalizing radicals. And this is a process that you probably haven't done for a really long time and may or may not have been emphasized very much for you in your Algebra 1 days. So the first thing that we're going to do here at the top, and if you don't have this paper, you can just do these problems on your own paper, but it is important that you write them all down. All right, first thing we're going to do is up here, we're going to write a couple general rules for radicals. These are things you've seen before, but you've likely forgotten. Okay, so the first one that we want to remember is that the square root of, let's say, A over the square root of B, if I have two radicals, two square roots, it is important that they're both square roots. If I have two square roots over each other in this nice dividing them, I can rewrite that effectively as an A square root of A over B. I can put both radicands under a single radical, or I can separate them. This is going to help us on these problems down below because we're going to do them without a calculator. The next thing that rule that we want to remember is, and this is going to help us with what's called rationalizing, is that the square root of A times the square root of A is actually just going to equal A. And the reason why is that if we multiply these two radicals together, we would have the square root of A squared. Well, of course, the square root of A squared should just be A. So this is a really important idea. It's going to help us work with our problems down below. All right, let's just start jumping into this, and we're going to apply these. So this first problem that I have here, the square root of 12 over the square root of 24, means that we're going to be able to first apply that very first rule that I pointed out up here above. I'm going to slide that back down for us. Okay, I have two radicals, okay, that are separate. They're both underneath my radicals, but I can imagine that this is a single fraction. Now, we're not going to generally write this but what we're thinking here in our heads is that this really effectively looks like that, which means we can reduce this fraction and we would have a 1 in the numerator and a 2 in the denominator. So our original problem could simply be rewritten as 1 because the square root of 1 is 1, and then our denominator would be the square root of 2. Now, this is where our second rule comes into play. We cannot leave a radical in the denominator. It's kind of an old school rule from just historically before we had modern calculators, but also it allows us to write consistently everyone's answers the same way. So our rule is that we're never going to be able to leave a square root in the denominator. Well, from up here, I know that I can simplify a square root, make it into just the value of A by multiplying by itself. So I'm going to take this denominator and I'm going to multiply it by a square root of 2 because that means that my new denominator can just be 2. Well, you'll notice I didn't finish my numerator here. Anything that I multiply the denominator by, I need to multiply the numerator by because this is effectively 1. It's a really messy version of 1, but it is 1. So when I multiply straight across, my denominator becomes 2, following this rule, and I multiply straight across and my numerator becomes the square root of 2. This is going to be our final answer. All right, let's take a look at our next one. Students want to try to reduce this, but remember, this 2 is under a radical and this 20 is not. So no reducing can happen there, but we can rationalize. So remember, I multiply the denominator by whatever radical is there, and that's going to give me a 2. And then I'm going to multiply straight across, outsides with outsides, insides with insides, so my numerator becomes that. Now we have to be careful again because this reduces even further. I want you to notice we are not using a calculator. You should be able to do these problems without a calculator at all. All right, let's continue on. We're going to look at this one, and now we're going to notice, ooh, look, these could reduce. That numerator, they both are going to reduce by 7, so this can be rewritten as 5. This is effectively going to become a 2, and this will be a 5. So I'll have 5 square root of 2 over 2 square root of 5. Now it's only the radical in the denominator I worry about. So this is going to get multiplied by 5. So my denominator will become 2 times 5. And you'll probably get to where you do these in your head, a lot of this. I'm going to multiply the numerator by that. So my numerator is now 5 square root of 10. Now, let's take a look at this. I left this separate, and I did that because it allows us to better see that these 5s cancel. So our final answer is the square root of 10 over 2. We're going to use this process a lot in Chapter 8. All right, let's keep going. I'm just going to keep talking through each of these, and if you want to work ahead, you can work ahead, and when it gets to it in the video, you can just check that. Okay, this is going to be square root of 15 over square root of 15. So the problem becomes 3 square root of 30 over 15. I reduce, and my answer is square root of 30 over 5. Next one. Oh, I can reduce again, so let's recognize that we can reduce. These are both going to reduce by 5, so this numerator is going to become 33 square root of 4, and the denominator is going to become a square root of 3. Now, of course, square root of 4 is just 2. And then I'm going to go ahead and write out my square root of 3, square root of 3. That means that my numerator is now 66 square root of 3 all over 3. And then this is going to reduce further. So 3 goes into 66, 22 times. My answer is 22 square root of 3. I want you to notice how quick these problems actually are when we get going on them, okay? Just continuing on. Get rid of that radical in the denominator. Notice the 2 in the denominator is perfectly fine. It's only the radical I'm concerned about. So now this is going to become 51 square root of 3, and my denominator is 2 times 3. I'm going to leave this separate for now because it makes it a little easier for me to recognize that this 51 will reduce by 3. Okay? It's kind of a sneaky little factor. 3 goes into itself once, and it actually goes into 51 17 times. So my answer is 17 square root of 3 over 2. Continuing on, moving on down. There we can see it again. Things are going to reduce. Each of those radicals can reduce by 6. So the numerator is going to become, I'm going to think of this as this is going to become 2, so I'll have a square root of 2. The denominator will become 4 square root of 5, just reducing each of these by 6. Now I'm going to rationalize. Square root of 5, square root of 5. This is going to really, really reduce your work. Multiply straight across again. I get square root of 10. The denominator is 4 times 5. You probably don't need to write that middle step, but I'm writing it here so that you can see that. So my 4 times 5 is now going to give me, oh, I just caught my little mistake. I said, nope, I didn't. Sorry. Thought I had a little mistake there, and I just realized I'm good. Never mind. This will become square root of 10 over 20. Okay? Next one, there's no reducing. Again, don't be tempted to reduce this because this is under a radical and this 27 is not. Square root of 3, square root of 3, 27. Multiply only the insides of those radicals, 21 over 3, then reduce. So our answer is 9 square root of 21. Just cruising along. All these problems were written to be done without a calculator. That's really important. All right, multiplying straight across, I'm going to get 8 square root of 42 all over 6, and then my 8 and my 6 will reduce. This will become a 4, this will become a 3, so my answer is 4 square root of 42 over 3. Continuing on, we're going to reduce just the 6 and the 10. So this will become 10 square root, they're both going to reduce by 2. This will be 10 square root of 3 over 3 square root of 5. Then we rationalize. So we will have 10 square root of 15. Our denominator is 3 times 5, which reduces. I can't emphasize this enough, guys. Leaving these separate instead of writing the 15 really allows you to see that ability to reduce so much better than if you create really big numbers. So we end up with 2 square root of 15 over 3. All right, cruising along. Look again, we can reduce. So this is just going to become a 1. So my numerator will be a 1. My denominator will become 5 square root of 3. So we have 6 square root of 3 over 5 times 3. The 3's cancel. And we get 2 square root of 3 over 5. One more to go, and then I'm going to give you one more piece of really crucial information. All right, now this next one, what I want you to notice on this one's a little tricky, so maybe even put a little star on this one. This is our only one that looks like this. This square root of 18 actually simplifies. So before we try to start rationalizing, let's make this smaller. So this will become 24 square root of 5. We've been rationalizing radicals for a long time now, so you can probably do this one in your head. It's going to become 3 square root of 2, because remember that square root of 18 was 9 times 2. Now, that means that we get to reduce outside first. So 3 goes into 24 8 times. Now I can rationalize. And we're going to get 8 square root of 10 over 2, which reduces one more time, and we get a final answer of 4 square root of 10. So I want you to notice how quickly we were able to do all of these problems, and we didn't have to use a calculator a single time. Now, the last thing that I want to point out, and this is really crucial for us in terms of moving forward in our work, I want you to notice that every time I wrote my answer, I had a horizontal fraction bar, okay? So I want horizontal fractions every time. Trust me on this. And anything should clearly be in the numerator or the denominator. We never want to write 2/5 square root of 3. This would not be a good answer, okay? It's going to cause lots of confusions later. We always want to write our answers like this. Everything in a numerator, everything in a denominator, and never write them like this, or we don't want to do this either. This method also, this is that angled fraction bar, this is going to make things really confusing when we try to multiply or add our fractions down the road. So I don't want to see that one either. Okay, if you've got questions or there was something on this that confused you, then just jot down your questions and bring them to class.